Okay, for the next example, now I want you to know from the last example, I should say, you could do exercise 1 in the book. It's the same exact type problem. Okay, to make sure you got it down pat, and you can check with Bob, and if you have questions you can text me and let me know. Okay, the next one I want to do is this one here. It's another classical example where you're trying to find the maximum area of a rectangle underneath a curve, or sometimes in between two curves, but that's another problem. So look, this is super easy stuff. Okay, make this a little bit bigger. Okay, so here's the idea. Get a pencil. A rectangle has its base on the x-axis and the upper vertices on the parabola. So even like on your semester review, they give you a curve, but they don't have the rectangle shown, or at least I don't think they do. Just draw a rectangle on the paper. Make sure that the vertices are on the x-axis and touch the curve itself. And the upper vertices are on this parabola 6 minus x squared. Find the maximum possible area of the rectangle. Okay, well, domain. First of all, I know I could have a rectangle of 0 area, right? That would be just maybe this rectangle here, just a straight line, right, with 0 width and some length. Or it could be this rectangle here on the x-axis from point to point on the curve of 0 length and 0 width. So we could have no rectangle, so that'd be 0. How do I find the upper bound? Just take the curve, because remember, area of a rectangle is length times width, right? I don't even know what the length is yet, but we're going to talk about that in a second, or this width, if you want to call it that. But this here, I don't know what that is either, but I do. It's just the function itself. It's the height of the function. So the length, I might not know what it is, but the height of this thing I know is 6 minus x squared. It's the height of the function. So I have this piece figured out. How do I find this? Well, there's a distance here. Remember, this is symmetric, right? The y-axis is going to cause these two pieces to be equal. So there's this distance here from 0 to some x value, which we're going to call x. And if this length is x, then this length is x. So the length of this whole side is just 2x. I have a formula. I have a domain, which I didn't finish. It's from 0 to, if I solve this thing, I have 6 minus x squared equals to 0. So x squared is equal to 6. So x is equal to plus or minus root 6. So because of symmetry, I'm going to start at 0. You could go from negative root 6 to root 6 if you wanted to from here to here, but it's easier to use symmetry and go from 0 to root 6. So now I have a domain and I have a formula. Okay, so let me remove the book and let me do the problem here. Okay, so again, you know, I have some curve. This is 6 minus x squared, x, y-axis, and here's my rectangle. Okay, this is x, and this height here is 6 minus x squared. So my area function is 2x times 6 minus x squared. And you know, you're gonna have to take a derivative of that, right? So rather than use product rule, you can go ahead and distribute. So it'd be 12x minus 2x cubed. That's area, right? And again, we're going from 0 to root 6. Okay. So now that I have my function, I can either pop that into my calculator, and I'll do that in a second, or I can just take the derivative by hand. I know that the derivative of this thing with respect to x is going to be 12 minus 6x squared, and we set the derivative equal to 0, and we solve to find the critical numbers. I'm going to pull out a 6, so we have 2 minus x squared. And if I solve, I'm going to have that x is equal to plus or minus root 2. Now because I'm using symmetry, the negative root 2 is not in this interval, so you discard it. So I know that x is equal to root 2. Okay? And again, the question said, find the maximum possible area of the rectangle. Well, if I want the maximum possible area, I'm going to take this critical number and I'm going to plug it into my area formula. 12 times root 2 minus 2 times, minus 2 times 2 root 2. So 12 root 2 minus 4 root 2 is 8 root 2. That's it. That's all you have to do. Now, if it were a problem like the next one, where we have a rectangle between two curves here like this, guess what? This width is still going to be 2x. That's not going to change. It's always going to be the same. But the height is going to be top curve minus bottom curve. Okay, so the top curve would be this one here, and the bottom curve would be this one here. Okay, upper curve minus lower curve in that case. Now, the functions that are given are 4 minus x squared. Well, since this is a parabola frowning upside down, this one here is my 4 minus x squared. And this one is my parabola going up. So to find the height, or the width, or the length, whatever side you want to call it, to find this, I know this is 2x. But to find this width or this height part, it would just be 4 minus x squared minus this whole quantity. And then of course you would change the sign and whatnot. So I want you to try that one for practice. Okay, so do this one in your notebook and let me know if you need help.